right, good afternoon. Nice to see so many people here, see some familiar faces. Welcome to the talk Green Software. If you change the way you code, the climate doesn't have to change. So if you're here because you think I'm going to talk about CSS or color templates, no, that's not the type of green. We are, in fact, going to look into sustainability of our coding practices. So short agenda. We'll provide some context. Why are we here? We will dive into development practices for green software. My colleague will provide some examples and dive also into the development practices. And finally, we'll end with some major takeaways. If there are questions, please raise your hand and we'll see if we can answer them through the talk. And otherwise, afterwards, we still have some time for it. So, Despacito, Cristiano Ronaldo, and Stranger Things. What do these have to do with each other? I think right now it doesn't make any sense. Some you might know, some you haven't seen. But just keep this in mind and we'll come back to this later. For now, I'm your host, Edwin van den Houdt. I'm a manager at Netcompany, 35 years old. And I've been a technology enthusiast for the past at least 10 years professionally, I think my entire life privately. And also the last few years I've been really into how I can change my way of living to be more sustainable and also looking into how we can take this further into the professional work. I'm here joined by my colleague Kanupriya.
Yeah, hello everyone. I'm Kanupriya. I'm working as a senior architect in Netcompany from 1.5 years now. I have total experience of 13 years in technology. I worked as a full stack developer, started as a C# developer, and now I'm exploring how we can use the green software principles in everyday development with the team. So yeah, this is about me.
Thank you. So a little about Netcompany, our employer. We develop big systems for society. We are all dedicated to build responsible software. And with that responsibility comes that you have to think about ethics, think about sustainability, think about how people will actually be able to use your software. So today we'll dive into the sustainability aspect of it. But you can think of big applications that we deliver, like donor registry, StudyLink, and we've got the Earhart system in Copenhagen. So all these big critical systems have lots of societal impact, and we really do try as a group to make sure that we build it as sustainable as possible. So why are we here? I think the best thing about figuring out what to do next is to look at the context where we are in, and it will help us develop this idea of the importance of our work, basically. It all boils down to greenhouse gases, carbon. So carbon is short for carbon dioxide, and the main point of our initiatives at this point is to reduce carbon. Carbon, as you know, is a greenhouse gas which is growing much more and more in our atmosphere, and this allows actually for the temperature to rise. This is what the climate change is enabling, and everything we do to reduce this impact boils all the way down to reducing carbon to reduce the impact. Good to realize that there's a difference in carbon energy. When we look at carbon energy, we have energy that's produced by coals on the one side. So here it is really easy. This is the most polluting way of generating energy we have. And that one, obviously, we want to stay away as much as possible. And all the way on the other side, we have our renewables like solar and wind, which have a much lower carbon footprint than the other side. So when we are looking into green software, I think these are the main concepts we need to think of and need to remember is what we are working towards. So TLDR, basically after this slide, it's done. You know everything. Green software, use fewer resources, use less energy, and use your energy more efficiently. This is it. You're done. Thank you. No, all kidding aside, more details. So climate change, climate risk, this is something we are seeing much more in the news, in the media. And what we see is that the average temperatures are rising. We really do want to keep it below the 1.5 Celsius. Don't think we are going to reach it, unfortunately. So who knows what effects that will have. When we look at the oceans, due to the rise of temperature, they are storing much more energy. I think the top 100 meters of ocean now stores up to 90% more energy than it did before. And this can have catastrophical events as a result. So warming of the ocean means that there's more carbon also in it, which means that flora and fauna will suffer. We will have more hurricanes, more dramatic events for weather, and basically also we'll see the sea level rising. In the Netherlands, we are pretty well prepared for it, although other countries less so. So also here we will start seeing much more issues with water levels rising from rivers that cannot take the water up and bring it again to us. And finally, we're seeing much more forest fires. So I think every year there's about the equivalent of Mexico area that burns down, which again is double negative because we are losing very important carbon capture mechanisms, which is the forest, and we are gaining much more carbon, which is the burnt forest, back into the atmosphere. So altogether, really important stuff. And I know you're all thinking, what does this have to do with us? We're just building software. How much impact does software have on the world? Well, I think that helps best with a few examples to put it into perspective. So when we look at some data from 2018, for instance, if we look at all online video content that was consumed in that year, we're looking at 300 million tons of CO2 that was used to watch these videos. So that's the same amount of greenhouse that Spain emits in a year, which is 1% of global emissions. So that's only video. If we look at Bitcoin, I think this is no surprise. It uses lots of energy. But again, pretty recent data shows that it consumes 170 terawatts of energy in 2023, which is, again, the same amount that the entire country of Poland uses in a year. That's a 0.1 global energy consumption. Obviously, there are lots of other ways that we're trying to reduce it, but these are new technologies that we are embracing as a society and the impact that it has. When we look at data centers, we are seeing a pretty steady growth of 20 to 40% annually in energy consumption. And the worrying part here is that we are actually our data centers are getting much more climate neutral. So most of them are running on sustainable energy. We are using much more sustainable hardware. However, the energy consumption still is growing and the demand is growing as such. I think a difficult part with this all is that once we figure out how to get something more efficient, the paradoxical move is that we will use it more. So at the end, we will start using more of something which is more efficient, and altogether, not much will change. Ironically, I did want to add a picture here, so I used AI generator. And this costs one smartphone of fully charged to generate, give or take. Obviously, bigger models will use more energy. But this is it. This is our job. We are using it. We are here at the forefront to do something. back at Despacito, we started it. A worldwide hit, 2017. Everybody knows it, everybody dances to it. But for me, this was like eye-opening to realize how much impact one thing can have. In the 8 billion plus views, the energy consumption we see here is equivalent to 5 African countries. So like 5 actual places where people live and work and go to school, which is, in my mind, really impressive, scarily impressive, but and the same goes for Cristiano Ronaldo. He's one of the biggest users of Instagram. He's much more than 670 million followers. And if we calculate that every person that watches his selfies that he posts online throughout the year, it will be about 120 million watt of selfies of energy, which is about 5 to 6 households of energy in the UK for a period of 5 years. Stranger things, I didn't do the energy math, but 1.8 million views or hours viewed in 1 year, which is crazy. The Witcher had only like 600 million or 600,000 hours of views. When we look at this, you start to think, well, this is so big, what can we do? It really feels like there's not much for us in it, that we're already headed towards the ravine. But that's something, hopefully we can bring a much more positive spin to it, which we will dive into right now. So the Green Software Foundation developed 6 development principles, which gives us the tools and the mechanics to make the difference and to start basically tomorrow at your job. The 6 of them are carbon efficiency. So how do we build applications that are much more carbon efficient? We'll look into energy efficiency. How do we build applications that are much more energy efficient? I think you'll see, well, what's the difference? Kanupriya will dive into that. Carbon awareness, so can we build applications that are aware which way they can get energy which is less carbon intense. Hardware efficiency, so let's build applications that use the hardware better. Measurements, improving anything will be difficult without measurements. We all know, do not do premature optimization, so we will have some principles which we can do during development, and then there are some measures you can take once your applications are in production. And finally, climate commitments, so that's defining the exact mechanisms of carbon reduction. And I would like to give the word to Kanupriya, who will dive into all these different principles and give us more context to them.
Yes, thank you, Edwin. Okay. To start with the carbon efficiency, does anyone here knows about anything about carbon and energy, and what is the difference between carbon and energy? Yes.
I mean, carbon is a waste product often created when generating energy. So being energy efficient probably means that we need to burn less fuels that generate the carbon dioxide.
Yeah, I think that's a good one. For me, when I started working on these principles, I wasn't really sure. So we dived into a lot of things about getting more knowledge about how carbon dioxide is generated, how we can create softwares which are performing good, but they're using less energy. So the first principle that I want to touch upon is carbon efficiency and how we can, make efficient softwares based on it. I can just use one example. So for example, we have a Google Cloud. We are using cloud, and we have a Google Cloud region picker. If we look at the region picker and we see the regions which are nearby, which are green regions basically, not every region is green, so we choose a nearby region so that when the data is being transferred, it takes less energy. So these small things, these small decisions that we make during our design process or our setting up our operations make a bigger impact for the overall running of the software. The next principle is the energy efficiency, which is basically the electricity efficiency. So when we start up our machines, we think that it's just a computer that is the starting point, but the starting point is the plug that goes into the socket and gets the energy. That energy is emitting carbon, and we don't know what is the source of the energy. It could be solar energy coming from fossils, burning coal, or we don't know what is the source. So if we're using that energy and we want to make sure that we provide good value to that energy and also make the efficient applications. For example, if we are building some algorithms, we can look into cryptographic algorithms so that our algorithms are performing good, but they're using less energy consumption. So this is also one thing to keep in mind while developing code, because we just start developing, use some resources which are producing more energy, but we are not considerate about these things, I think so. So, yeah. Yeah.
Also picking the language that best fits.
Yes. Yes, it does. The programming language is also, a big choice to make for sustainable software. Yeah, it does.
I think indeed the language has a big impact on the actual usage of energy. So I think the trade-off there will be developer efficiency, and so if you have people that are very proficient in Rust, then maybe it's a good idea to switch from Python to Rust.
Yeah.
But yeah, I think that's indeed something you should look into if that's possible.
And the next principle is carbon awareness. As I mentioned, we should know from where this energy is being generated. So if we are aware, if it is possible, we should always use the renewable energy source in the development process. So just to be aware of the resources is an important factor for the principles. Also, the hardware efficiency. So when we construct something, it emits carbon. When we destruct something, it emits carbon. So when we have already emitted a lot of carbon in creating hardwares, and then it comes with an expiry date. So after 3 years or 4 years, it's going to expire not because the hardware is not working anymore. It's because the speed that we are developing softwares is way ahead. So we are working really hard on the software part that the software is not compatible to that hardware anymore. And which is an important factor to keep in mind, that the destruction of the hardware is also emitting carbon. So we should always, I think, look for the softwares, or we should try to push the limit of the expiry date as much as possible.
I think a good example is you have your iPhone. The production of the phone itself costs a lot of energy. If we start building software that is able to run on much older devices for a longer time, we enable these older devices to be useful for longer, which in turn, if you look at the entire life cycle, that's how we can get the most impact. So I don't think anybody's looking forward to making your application run on Internet Explorer 6 or 9, but I think it's aware that keeping older hardware alive for longer is something that we have impact on.
Yes.
Yep. If you keep hardware alive too long, isn't it then also struggling that it can be replaced with more energy-efficient hardware?
Obviously, with all our engineering efforts, it depends. So I'm sure there's this cutoff place where the newer hardware is much more efficient, considering the entire development cycle within it.
And in that case, we should make sure that we are recycling that hardware and we are not just throwing it in the trash or somewhere. So that's an important thing to keep in mind. And the next principle is the measurement. I think the name says it all. So what I believe is if we cannot measure something, we cannot work on it. So even if we start working on a problem, we want to break it down into smaller things. We want to see, if it is doable or not. So we want to make our software we will touch up on some tools in upcoming slides where we can measure the performance of our software. So how efficient our software is in terms of the greenhouse design principle. So these principles, if we measure them, it's easy to optimize it, basically. And then the most important thing is the climate commitments, because we use some sort of, how do you call it? We use EcoCode, for example, or SonarCube. I don't know if anyone have heard about it. So we use it in our daily life, professional life, basically. And we are committed to it. It's not difficult to implement these principles in your everyday daily development practices, but it's just nobody normalizes it, nobody talks about it, and I think it's really important now to have stakeholders also on, with us on the same page, aligned, that we want to use these principles in the daily practice of development so that we can have a bigger impact. So the principles that we have just touched upon are not dependent on any application domain, on any cloud provider, any industry, organization size or type. So, or also the language or the framework, as you asked. There are also two philosophies of the green software engineering. Everyone has a part to play in the climate solution, and what it means is it doesn't matter if you're a developer, an architect, you are from operations, you have a role to play. If you look at those principles, you can implement it, any stage of the development life cycle. And also the sustainability is enough all by itself to just justify our work. So sustainability is a broader term than the green software development. I would say sustainability covers the environmental and also the economical impact of the development, the privacy of the software, but green software development is only considerate about providing less environmental impact of the software. So with sustainable software, there are also added advantages, like it's more efficient, it's more performant, but that's an addition. But what we are looking for is sustainability, and it's enough for us to move towards the green development. Yeah, let's touch upon some software examples. So the first thing I would like to talk about is the efficient algorithms. So we start developing, the first thing when we started school, in IT school, was we didn't just start with learning C# or C++, we started with pseudocode. So we used to write pseudocode just in normal English language to see how programming works. So we have to look at the algorithms that we are writing first. Getting into the language is the next part. So if we take the algorithms which take fewer resources and computers and results in the minimum time for a problem, then that algorithm is known as efficient. So it's basically time and result constraint. So if we can provide better results in less time using less resources, then it's an efficient algorithm. And same goes for the runtime of the CPU, the processing time of the CPU model, and how much RAM our processor is using, and things like that. So I also want to discuss about the high-performing sorting algorithm we use. So for example, insertion sort. So it has a fewer sorting requests, but the battery usage is very optimal. And if we look at the quick sort, it has higher sorting requests, so it sorts really fast, but the utilization of CPU is too much. So instead of going for the higher performing sorted algorithms, we have to look for algorithms which are adaptive, which are optimized, and provide a good balance between energy efficiency and performance. Because we don't want to Yeah, we definitely want to have good performance, but we have to keep in mind the energy efficiency.
I think a great part here is that we can actually start choosing algorithms that are slower, because if time isn't essential, you can reduce your energy impact. So I think this is also part of demand shifting, where you can say, well, it doesn't matter if it takes longer because we put it in a queue and it's ready in 30 minutes.
Yes.
If I'm correct, then you choose the slower algorithm because it actually uses less memory space, and therefore, because otherwise I would think the faster algorithms have less CPU instructions and all that, and therefore less energy usage.
It depends on the algorithm that we're talking about. So if, for example, I mentioned about quick sort and insertion sort. So quick sort is faster and the CPU utilization is also faster. But what you mentioned, so I would definitely go for the algorithm which uses less resources and still it's good performing. It really depends on the use case. If your requirement is being really fast, then you have to find an adaptive, optimized way of doing that. Yes, let's get into some coding examples. Can anyone see what's wrong with the coding part, function, basically, algorithm?
Maybe not what's wrong, but which algorithm is more energy efficient?
Yeah, good one, thank you. I'm little forgetting what to say.
Algorithm A does a lot of constant computation, like A times A is a constant, but it's calculating properly every rule of every cycle to loop.
Yes, great observation.
Yeah, that's correct. So in the for loop, if for example A is really high number, then we are recalculating the same thing. So it's better to have it in a constant, and so we should remove the redundant operation. So this is an example of an energy efficient algorithm, basically, and which we tend to overlook. Yeah.
Can't we assume that a compiler will fix this for us? Like most compilers, even JIT compilers, will probably find these constants in these cycles and try to extract them. So why shouldn't we do that?
Yeah, if your compiler say it, then definitely you should remove it. It will be removed, but in some cases, if it is left in the code somewhere, unchecked by the compiler, and these are also examples, and there are tools to identify these kind of things and problems with the code and make it more sustainable. And these are just examples that use it. It's a small algorithm. So if you have a big algorithm,
in this case, since it might be in memory, the compiler would probably find it. But if these would be calls to an external API, for instance, and you are running, I don't think the compiler will figure out that it's getting the same result every time.
And again, maybe the compiler uses a little bit more energy because it needs to find it.
yeah, that's also.
Just a little.
Once your compiler starts optimizing, sounds like it's already using the energy.
It depends on your CI/CD pipeline.
In this case, it will be the runtime environment. It's a just-in-time compiler that also
Yeah.
does code optimizations.
For us, it's difficult to hear the audience.
Oh, yeah.
If you could either repeat or...
Yes, I'll repeat the question.
Yeah, are you going to repeat the question or?
Next slide.
Okay. Sure, sir. Yes. Referencing arrays. Yes, again, if someone would like to say something about the code.
K loop is continuously referencing the same part
Yes.
but it does assign it to a variable again. So what is then?
So the first one in A, it's referencing the value k, but it's using it all the time in the loop.
Yeah, okay, is a constant.
Right.
So,
So in this case, k is indeed the constant, which in the other one is pulled out of the loop and calculated once.
Yeah, in the first one, in the for loop, we are comparing two arrays, which is, of course, a expensive operation if, again, the loop is running on a higher number. And in the second one, we are comparing it with the minimum number minimum constant that we have already created on outside the for loop. So it consumes, less energy because it's not referencing to the array. And the next one is a late termination. It's a linear search algorithm where, if you see the difference, I would just say there is a break once the key is found. And this algorithm, even if the key is found at the first location, it will continue the loop n times, even after the key is found at the first location. But if we terminate at the right time, then the for loop will stop at the right when the key is found, and it won't continue until the n number of times. So these kind of examples and also the scenarios can be easily caught by some of these tools that we have studied a little bit about. So the first tool I want to talk about is CO2.js. It's a JavaScript library that enables developers to estimate the emissions related to use of their applications and websites. The second one is grid intensity CLI. It's a CLI, as it says, that enables developers and also operations to surface, monitor, and understand the carbon intensity of the code they run. Then Azure recently released a service, Azure Carbon Optimization, not recently, I think a couple of months back, which checks the resource utilization of Azure resources, basically. So I think it can be also very helpful for the operations or the DevOps people who are here. Then we have IP to CO2 intensity API. This allows us to query a physical IP address and returns the annual grid intensity based on the location of the IP address. And the next one is EcoCode, which is also used by Netcompany, basically. So it's a SonarQube plugin, which, how many of you are using SonarQube? Nice. So do you use it in your, for what purposes are you use it for? Sorry? Yeah. So EcoCode is a plugin that you can, do you use EcoCode? Yes. Okay, nice. So it highlights the code structures and also highlights of course, provide quality control, the security also, and also provides you the test coverage, statistics, the analysis, along with the sustainable coding principles. So, and also, I added generative AI because it's not something which will help you optimize your code, but it can at least help you with if you ask AI, to convert your code to more sustainable code, then it might help you to have a better optimized version of the code, basically. Yeah, and I won't suggest to rely on that, but you have to run your analysis and see if it actually works.
All right.
Yeah, I'll hand over to Edwin.
Thank you.
Welcome.
So let's move on to summarize. So we've heard a lot. We've got the context. We've seen some examples. So I'm basically now going through all the topics we touched upon to hopefully run it home so you can remember this. So there are certain design and coding practices that you can take with you. One of them, control features, which is where you look at how your application is running based on the type of device you're on, for instance. So if you have an application that also runs on mobile, maybe you want to turn off certain features so that it is a bit more kind to someone's battery. Reduce data usage. I think this is one of the most impactful items we can do as a developer. From API design, how do you design your API so you don't have to send too much data all the time when someone's requesting it? Do you develop an efficient caching policy? Maybe you simply need to calculate something once, store it in cache for the week, and that will help. How much data you're sending over the wire to the client. You can be lazy and just send your 30 MBs of JavaScript, or we can figure out how to get these in small chunks and not send too much data. All of these things, like if the amount of usage is low, obviously the impact is less. But as soon as the usage goes up, you'll quickly see an increase in data that's sent over the wire, unnecessary. Maybe your retry policies for your API is kicking off a lot of work which it doesn't need. So these are all points in your application where you can see and check if you actually need to be doing all that calculation or sending all that data all the time. So detecting and removing loops, that's something that helps, obviously. And removing code. The straightforward, less code is less data you have to store, which in this sense means less data on your CI/CD, less data that you have to push somewhere, so that compounds easily. Adapt the whole application. I think I've got blank what I wanted to say here. And then obviously monitoring real time. Whilst you can monitor during development with SonarQube and SonarCloud, it's also important to figure out how you can actually monitor the energy usage in production. This can be pretty different than you expected, and figuring out where these hotspots are can help you refactor or change the code once it's actually being used. And then we have limit computational accuracy, and this is where we are looking at the precision. So let's say you have to calculate GPS coordinate, and actually you'll be able to put the pin on the map with like 2 decimals accuracy. Don't calculate the rest of the 10 decimals because it's unnecessary. You're not using it anyway. And these are places where you can actually make an impact. So, key takeaways. It's all about reducing carbon. That's the main goal when you are doing something. But then, obviously, as a developer, you can't say, well, I have to make an impact, and I will. You need to convince your boss at some time. So these are the benefits. Less energy and data usage means less costs. So you need a less big, how do you call it? Caching, the database, that's all like cost reduction. You increase customer loyalty if you can prove that you are actually working towards sustainable goals. It will increase your user experience. For instance, the example of the mobile phone. Using less energy means I can use your app for longer, which will make me happy. It will increase responsiveness online. Downloading like 1 KB is much quicker than 10. And all these steps also compound there. It will be easier software maintenance because we are very actively deleting code we're not using, so less code to manage. And finally, it will increase corporate social responsibility metrics. So big tech companies, they're going green. I think Apple runs all their data centers on 100% renewable energy. I think Microsoft, Amazon, they're moving in the same direction, the same as Google. We at Netcompany, we're introducing boot camps where we're trying to teach these software principles and incorporate it in our projects. And yeah, I think everything helps. So you can be the next generation of developers who understand the impact of software and have the tools to actually do something about it. So we can make these principles part of our daily habits. Just remember the principles, the choice of language can have an impact, choice of AI model. Hopefully now you have the right tools to search online and figure it out for yourself. Which brings me to my final slide. We can make a difference. It started out pretty doom and gloom, but I am confident that if we all chip in, we can make a difference and save the world maybe. Thank you.
Which language is the most energy efficient?
Assembly. No.
Machine language, basically.
No, I think that the closer you get to the CPU, the more efficient you can write your language. But then you quickly get to the bottleneck that nobody will want to work for you. So that's why it's important also to realize that you might not be in the position to switch from Python to Rust or C or C++. But yeah, I think we will get a lot from the compiler. I think the biggest impact will be on more architectural level, where you figure out caching in the right places, compressing your data when you send it to the client, doing less calls, maybe not writing some software, but that's, yeah. So yeah, low level is better. More questions?
Isn't it usually the more faster CPU with less CPU cycles solution, the more energy efficient solution?
So the tricky part indeed when looking at CPUs and where it's running is it really depends on the context. For instance, if you're using cloud services, which will enable you to maximize the utilization of what you're using, that might be more efficient. But if it means that now instead of a small CPU, you want a big one, which has a GPU also in it, then obviously it switches a lot. So I think it depends on where your operations are. But usually, yeah, if it's faster, it might be quick. It might be more efficient, definitely. Right? If there aren't any further questions, thank you so much for your participation. You're a great crowd, and hopefully we've got about 20 more green software engineers. Thanks so much.
Thank you.